Download this code and get free GPT-4o from codegive.com, link in the description below. Sure. An indirect graph is a graph where the edges have no direction. This means that if there's an edge between two vertices, you can traverse it in both directions. In Java, we can represent an indirect graph using various data structures, such as an adjacency list or an adjacency matrix. Here, we'll focus on using an adjacency list because it's more space efficient for sparse graphs. ### tutorial, implementing an indirect graph in Java. #####1. Graph representation. We'll use a hash map to represent the adjacency list. The key of the map will be the vertex, and the value will be a list of adjacent vertices. ####2. Basic operations. We'll implement the following basic operations for our graph. Add vertex, add a new vertex to the graph. Add edge, add an edge between two vertices. Remove edge, remove the edge between two vertices. Display graph, display the graph in adjacency list format. ####3. Code example. Here's a simple implementation of an indirect graph in Java. #### explanation of the code. 1. Class definition. We define a class undirected graph that contains a hash map representing the adjacency list. 2. Add vertex. The add vertex method checks if a vertex is already present. If not, it adds a new entry with an empty list. 3. Add edge. The add edge method ensures that both vertices exist in the adjacency list. It then adds each vertex to the others list to represent the indirect nature of the graph. 4. Remove edge. The remove edge method removes a vertex from the others list, effectively deleting the edge. 5. Display graph. The display graph method iterates through the adjacency list and prints each vertex along with its adjacent vertices. 6. Main method. In the main method, we create an instance of undirected graph, add vertices and edges, display the graph, and demonstrate removing an edge. #### conclusion. This is a simple implementation of an indirect graph using an adjacency list in Java. You can expand this implementation by adding methods for searching the graph, like DFS or BFS, checking for cycles, or even implementing weighted edges. This foundational structure will help you understand more complex graph algorithms and data structures.